Find the roots of the polynomial f of x is equal to x to the power of 5 minus 9x to the power of 4 plus 23x cubed minus 11x square minus 24x plus 20. Wow. It is a big polynomial, right? You are seeing 6 terms. And what is the degree of this polynomial? The degree is equal to 5, right? 5 is the degree, that is the highest power in this term. And looking at the degree 5, what you can see is maximum number of roots that I can expect is 5. 5 possible roots. That is, if at all you can get some solutions or the roots of this polynomial, this is the maximum number of solutions that you will find. Okay, so let us try, and it is a little longer, but please be patient and you will get it. It's not a complicated problem. It is not difficult, only the process, right? That is important, and let us do it one step at a time. All right. Now, let us make use of this rational root theorem. Using rational root theorem, I'll have to find what is the value of p. P is the constant term. What is the constant term here in this? A term without a variable x. That value of p is equal to 20. And find q. Q is the leading coefficient. The leading coefficient means go to the term where you see the highest power of x, and whatever is the numerical coefficient there. Here nothing is there, so always you have 1 times x to the power of 5. So the value of q is equal to 1. Now we have to look for this possible rational roots, like maximum 5 we get. All those 5 roots we get from this p, q. And it is the word like rational roots that is telling us to write this p and q in the form of p over q. Right? That's why it is a rational root, in fact. So, what all factors we have for p, we'll write it down, list it down, and divide by 1. Q is equal to 1, and division of 1 is, it won't change any value of the numerator, right? Dividing by 1 gives you the same quotient. Okay, so let us just find the factors of 20 here. What are the factors of 20? You know, 22 divides 10 times. Again, 2 can divide 10. How many times? 5 times, that's all. So 20 is written as 2 times 5. So using this factorization of 20, let us write all the possible roots, possible numbers that can divide this p. Okay, and that p divide q gives you the same thing, right? So I can just write down it like this. The possible rational roots are, the first one, 1 can divide 20, right? And that 1 divide 1 is that 1 only. It can be a positive 1 or a negative 1. So, plus or minus 1. So, while I'm verifying, I'll verify for the positive x value and also for the negative x value. I mean, positive 1 and negative 1 values. As we do it, you'll understand more. So, just please hold on. Now, what is the next number that can divide this 20? That is a 2. You have 2. And 2 divided q is 1. 2 over 1 is 2 only. It can be a positive 2 or negative 2 also I can take. So, after this 2, you have 2 times 2, 4. Yes, 4 divides 20. It can be a positive 4 or a negative 4 also. These two numbers, 4 can divide up 20 and negative 4 also divides. After 4, what is the next possible root? You have 5, right? 5 divides 20. Even negative 5. After 5, 6, 7, nothing. Then 5 times 2 is 10. So I'll write 10 as the next possible root. And finally the same number 20. So altogether 1, 2, 3, 4, 5, 6. 6 times 2, 12. 12 possible rational roots we got. Out of those 12, only 5 are going to be right, and that we'll have to verify. Okay. So first, what am I going to do? Try to check with this 1. Let us see if on substitution of x is equal to 1 in the given polynomial function, are you going to get a 0? Then by making use of factor theorem, I will say x minus 1 is a factor of f of x. And I think I didn't tell you about standard form. We are seeing that it is in the standard form. Always it is better to write at this particular point. I don't have to have it in standard form, but always it is good to write it in standard form so that in the next steps, when you go to synthetic division and all that this is really important to have a standard form. Okay, let's go. So now x is equal to 1. So this function becomes f of 1. I am substituting 1 in place of x on the left hand side. Do the same thing here on the right hand side. 1 to the 5th power minus 9 times 1 to the 4th plus 23 times 1 cube minus 11 times 1 square at this point minus 24 times 1 plus 20. Right? We replaced that x with 1. Okay, so what happens on doing that? Let us see. So 1 to the 5th power is how much? 1 to the 5th power is 1 only. 1 is multiplied 5 times. 1 times 1 times 1. That is 1 only. Minus 1 to the 4th power is 1 times negative 9 is, this is minus 9. Same way plus 23 times 1 is 23 only. 11 times 1 is 11. Minus 24 plus 20. So add all the positives together. My positive numbers 1, 23 and 20. And I'll have the negatives. These are my negatives. You can even use calculator directly and you can get these numbers. Okay. 1 plus 23 is 24 plus 20 is 44, right? Minus, add these negatives. 9 plus 11, 20 plus 24 is 44. Negative 44 because of that minus sign. So 44 minus 44 is 0. That is telling me that f of 1 is equal to 0. Therefore, x minus 1 is a factor of f of x. Let me see. X minus 1 is a factor of f of x. Alright. Okay, here it is missing. Let me fix it up. Alright. X minus 1 is a factor. Now, where do you go from here? Because this x minus 1 is a factor, I'll go ahead and divide this function f of x by x minus 1. And how do you do that? Let me get that function down here. Okay, so already I know that it is a factor, and let me use our synthetic division and reduce this degree from 5 to 4. Okay, now how do you do the synthetic division? First step, I'll drop down only the numerical coefficients. So this is 1, -9. And by the way, see, the standard form is very much relevant here. I have to make sure that this function is in the standard form. After 5, 4, 3, 2, and this is 1 constant. Good. So 1 minus 9, 23 minus 11 minus 24 and 20. Within this, I'll have my horizontal line. Okay, this is 23. Alright. So x is equal to 1. First case, right? You have 1. How do you do the synthetic division? First step, you will just bring down that 1. Now 1 times 1. 1 times 1 is 1. And as you go down vertically, that is addition. I have to add whenever you go this way, right? This slant direction, when you go diagonally, it is a multiplication, and this is the add thing. -9 plus 1 gives you -8. -8. Now you are going this way. See, -8 times 1 is -8. Now addition. 23 minus 8. 23 plus minus 8. It is nothing but 23 minus 8 gives you 15. 15 times 1 gives you 15. Minus 11 plus 15 gives you 4. 4 times 1 is 4. Minus 24 plus 4 is minus 20. Minus 20 times 1 is -20 times 1 is -20. So what is this? Minus 20 plus 20 got cancelled. That 0 is your remainder. Now the given function, this polynomial, is changed into that 6 terms have reduced to 1, 2, 3, 4, 5. Only 5 terms. And already you know that this x minus 1 is a factor. Now the remaining part is, this quotient is what? It is 5 changes to x to the 4, right? Or you can think like this. This is the constant term, x square, x cube, x to the power of 4. So it is 1x to the power of 4 minus 8x cube plus 15x square plus 4x minus 20. So given function f of x is now separated into 2 factors, right? Okay, you got this one, x minus 1. Now you have this reduced format is x to the power of 4, etc. Right? And that I'll call it as a new function. Let us take it as a g of x, and we will work with only this g of x and try to reduce it and get to another factor. Altogether, remember, I'm looking for 5 factors, total 5. It is 1 down, 4 more to go. X to the power of 4 minus 8x cube plus 15x square plus 4x minus 20. Okay, so next thing, again going by the possible factors, this is minus 20. I'm doing the same thing, rational root theorem. These are my numbers. Okay, so I'll start off with a 1. Let me take x is equal to 1 and see what happens. That is g, right? G of 1. G of 1 is equal to 1 to the 4th power minus 8 times 1 cube plus 15 times 1 square plus 4 times 1 minus 20. Giving you how much? 1. 1 to the 4 is 1 only. Minus 8 times 1 cube is 1. So 8 times 1 is 8. Similarly, 15 here. 4 minus 20. my positives. 1 plus 15 is a 16. 16 plus 4 is 20. And negatives are this. Minus 8 minus 20. Add those two. Gives you 28 with a minus sign. 20 minus 28 is not equal to 0, right? You don't get a 0. So g of 1 is not equal to 0. Hence I can say x minus 1 is not a factor. It is not a factor of g of x. So 1 is not good. I didn't get a 0 with 1. So what is the next option? I will have to take x is equal to negative 1. Are you seeing the process now? Because I didn't get, I'll have to go to the next one. Suppose if I get a 0 like the previous case, I'll just go to synthetic division and reduce the polynomial. Okay, so now let us try with negative 1 only within this g of x. That is g of negative 1 is equal to negative 1 to the 4th power minus 8 times negative 1 cube plus 15 times 1 square, that's a negative 1, plus 4 times negative 1 minus 20. Alright, so wherever x is there, I substituted negative 1. Say this is negative 1 to the 4 and that is negative 1, etc. I think everything is good. Let us move on. What is negative 1 to the 4th power? See, the exponent is even number, minus is multiplied even number of times. So it is a positive, right? Negative 1 times negative 1 times negative 1 times negative 1 gives you a positive 1. And this is a negative 8 times negative 1 to the 3rd power. So when you multiply it 3 times, negative 1 is multiplied 3 times gives you a negative 1, right? Negative 8 times negative 1 will give you a positive 8, right? This is a positive 8. Next, negative 1 square, negative 1 times negative 1 is positive 1. 1 times 15 is a 15. And this negative times positive. Negative 4 times 1 is 4. Last term is minus 20 by itself. So let us combine those. These are my positive 1, positive 8, 15. And those two are the negatives. What is the result? 1 plus 8 is 9 plus 15 is 24 minus 24, right? Adding those two, 24 minus 24 is 0. So g of negative 1 is equal to 0 is telling me that, now opposite of this, x plus 1. X plus 1 is a factor. X plus 1 is a factor of g of x. Alright, so as I got this factor, I will go ahead and reduce this function now. The g of x. Let me copy g of x. X, of course, 1 minus 8, 15, 4 minus 20. I am using the synthetic division to find what? Okay. All right. This. I'll bring down. So this is negative 1, right? This is a negative 1. For negative 1, you got a 0. So bring down 1. 1 times negative 1 is negative 1. Negative 8 minus plus a negative 1, right? Adding these two gives you a negative 9. Now negative 9 times negative 1 is a positive 9. Negative times negative gives you a 24. add them up. 24 times negative 1, minus 24. Add to give you a negative 20. Negative 20 times negative 1 is positive 20. Cancelled. 0 is the remainder. And that function g of x with the degree 4 is now reduced to degree 3. See, constant x, x square, x cube. So, this g of x, I can write it as x plus 1 times. See, that minus 1 is telling me remainder 0. The whole thing is telling me that x plus 1 is a factor times 1x cube minus 9x square plus 24x minus 20. Okay, so now where do you go from here? This function g of x is reduced into that format. That cubic function, I will give another name to it. Let us call it as h of x is x cube minus 9x square plus 24x minus 20. Again 20. So my possible roots are 1, 2, 4, 5, 10, 20, right? Like that. We started off with those things. Again, because of this 20 here, those are my possible roots. So let us check with 1. H of 1. I'll take x is equal to 1 to give me h of 1 is equal to 1 cube minus 9 times 1 square plus 24 times 1 minus 20. That is 1 minus 9 plus 24 minus 20. What do you get from this? 1 plus 24 is 25 minus 29. So definitely this is not 0. Right? And one more thing, you can just put it in calculator. Right? Now x is equal to negative 1. H of negative 1. See, I have to write the statement x minus 1 is not a factor of h of x. Now I am looking for x plus 1. So I'll take x is equal to negative 1. Negative 1 to the third minus 9 times negative 1 square plus 24 times negative 1 minus 20 is equal to, let us see, negative 1. This is 1. 1 times negative 9 is negative 9 minus 24 minus 20. Huge negative number. This is also not 0. Making sense? Yeah. Just substituting these possible values. And next thing, I'll take x is equal to 2. Let us see. H of 2 is equal to 2 cube. Here I am substituting. Let me just, these are the ones. In those x's, I was substituting those 1, negative 1, and now it is a 2. 2 cube minus 9 times 2 square plus 24 times 2, missed, sorry, yeah. This one. This. 924 times 2 minus 20. This gives me 8. 2 cube is 8, right? 2 times 2 times 2 times 2. 8. Now 2 square is 4. 2 times 2 is 4. 4 times 9 is 36. 24 times 2, 48 minus 20. So my positives, 8 plus 48, 56 Minus 36 minus 20 is also 56 with a negative sign. You got a 0. Tells me that x minus 2 is a factor of h of x, right? So, what next? We are almost done. I'll take these coefficients now. 1 minus 9, 24 minus 20. Okay, for the last two factors, you don't have to do this. Only 3 factors out of 5. The last 2 factors we can do from the quadratic method. Only the remaining 3, the synthetic and the factor theorem, all that you are doing here. Okay, let's move on. This I have x is equal to 2. Let us do synthetic division. Bring down 1. 1 times 2, 2. Minus 9 plus 2, minus 7. Negative 7 times 2, negative 14. Add them to give you a 10, right? 24 plus negative 14 is 10. 10 times 2 is 20. A remainder 0, right? That's why x minus 2 is a factor. Now you see the function is reduced into 10 is a constant minus 7x x squared. 1x squared. See, the degree 3 is reduced to degree 2. X squared minus 7x plus 10. Okay. So 1x squared. In fact, that my function h of x can be written as x minus 2 times, because that x minus 2 was a factor. I'm talking about this x minus 2 and this piece, quadratic, x squared minus 7x plus 10. And this is very easy, right? The last 2 factors. I'll go to my x method. My sum is negative 7 and the product is 7. Okay, this is easily here I'm getting in this case. Sometimes you don't get factors. If you don't get, you don't have to worry. You can always make use of this quadratic formula. Negative b plus or minus square root of b square minus 4ac all over 2a. You can use that formula to find this, to solve the last one. In this case, it is very easy. You have your factors, right? 5 times 2 is 10. Both are negatives, so that it is a positive 10. Add them up to give you a negative 7. So, you have x minus 2 times, this is what? X minus 5 on the top. Next number is x minus 2. You have your factors. The whole of that big polynomial, this one, is now reduced into all the factors. You see, let us identify all of them. This one, I'll highlight those. 1 second. First factor, x minus 1. And let us also remember, after x minus 1, next factor, you got x plus 1. So using the same process, the x plus 1 you got it here. Next, the third one is x minus 2. The fourth one is x minus 5, and x minus 2 is repeated, in fact. Yes, they can repeat those factors. So, my given function f of x having a degree 5 is reduced into this form. First factor was x plus 1 times x minus 1 times this one, x minus 2 times x minus 5 times x minus 2. It is repeating, right? So let me write it here and show you again. This repetition of x minus 2, you can just take it up from there. x minus 2 times x minus 2. You can even write x minus 2 whole square. Okay, so now my answer, final answer, the roots are, what are they? My roots is equal to, and you know, I have to solve each one of them. X plus 1 is equal to 0. On solving this, you will get x is equal to negative 1. Solving this, x minus 1, you will get x is equal to positive 1. Solving this, you will get x is equal to 2. And it is duplicated, right? And x minus 5 on solving, you will get x is equal to 5. These are my solutions, right? And that function, if you put it in the Desmos, in the graphic calculator, and look for the graph, you see what happens. These are the numbers, you remember? Negative 1, 1, 2, and 5. See here, I have it. This is the graph of the given polynomial. X value is equal to negative 1, positive 1, 2, and 5. See, this 2 is repeated. Due to that reason, you see the graph, it came down, and on reaching 2, it touched 2, and from there it reflected back. It went back. So this is where the duplication happens. The x is repeated twice. The value of 2 is coming to us 2 times in the solution, right? So even though it is a lengthy process, it is just a process, like it's step by step how to do it. I showed you. Look for all the possible factors and do one thing at a time carefully. All this individually you did. You know how to process this one factor like that. But in this case, like, you got all those factors. Earlier in the previous cases, we were just dividing and reducing into the function of lower order, right? But this is a little extra, okay? So please try, and I hope this helps. Thank you.